Hi there, Mr. Sutton here with the IM3 7-6 Part 2 homework solutions on law of sines.
For this problem, we're trying to find this missing side of the triangle. Now, since it's not a right triangle, and since I know an angle and a side that are across from each other, I can use the law of sines to figure out anything else I need here. So let me go ahead and set that up. That's sine of A over A equals sine of B over B. So let's start with the side that we actually know everything about. So we'll do sine of 39 degrees over the side across from it, which is 26. And that'll equal the sine of this other angle that we know, 83 degrees, over our missing side, which we'll call x. Now, to get x by itself, I have to cross multiply basically and then divide. So we have 26 times sine of 86. And then I have to multiply x to the other side and divide by sine of 39. So this sine of 39 comes down here. And at this point, I just plug it in the calculator. So here I am on the calculator. I used alpha y equals to get my fancy fraction. I have 26 sine of 83 over sine of 39. I'm in degrees mode. Press enter. And that comes out to about 41.0. So since this is a side, the law of sines doesn't have any ambiguity. Just whatever you see is what you get. On this problem, I'm trying to find this missing angle. Since it's not a right triangle, and since I know a side and an angle that are across from each other, I'll use the law of sines. Sine of A over A equals sine of B over B. So let's start with the pair that I know. We have sine of 99 divided by the side across from it, 30, equaling the sine of the angle we're missing here, x, over the 33 that's across from that. So let me first isolate sine of x. To do that, I just have to multiply both sides by 33. So I have sine of x equals 33 sine of 99 over 30. And at this point, I'm going to have to take sine inverse of all this stuff on the right to get x. So let's do that on the calculator. So here's what all of that looks like on the calculator. I did second sine to get sine inverse, and I did alpha y equals to get my fancy fraction here. Taking inverse sine of all this stuff gives me nothing, a domain error. So what this is telling us, assuming that we plugged everything in correctly here, since we got an error, that means that there is no such angle, which means that this is actually a bogus triangle, could not possibly exist based on these dimensions, because, I mean, they never said it was drawn to scale, right? So that means since no such triangle exists, our problem here is done. For this problem, I'm trying to find a missing side. Now, I know for sure this is not a right triangle. We've already used up more than 90 degrees between these two angles, so this last one can't be 90. So that means I'm going to have to use something else. Now, I do have a side and an angle that I know that are across from each other, so that means I can use the law of sines. Sine of A over A equals sine of B over B. So now let me put in the side angle pair that I actually know everything about. We have sine of this 45-degree angle over the side across from it, the 14. And that's going to equal this other angle, sine of 60, with the side across from it, which is the x that we're looking for. Solving for x, I'm going to have to cross multiply. So I've got 14 times the sine of 60 if I go one way. And then if I go the other way, I would have x times the sine of 45. But I'm just going to divide by the sine of 45, and that's going to move it down here in the denominator of all this. So let me plug all this into the calculator. So here we go. I did alpha y equals to get my fancy fraction here, so I don't have to worry about PEMDAS. Pressing enter on all that stuff, we get 17.1. And we don't have to worry about alternate answers. Law of sines doesn't need alternate answers when you're just dealing with sides. It's only angles we have to worry about that with. So this is it. For this problem, trying to find this missing angle in this triangle, it's not a right triangle, or at least they never gave us any reason to believe it was, but we do have an angle and a side across from each other, so we can still use law of sines on this one. So sine of A over A equals sine of B over B. Starting with the pair that I've got everything about here in terms of information, we have sine of 138 degrees over the side across from that, 31.9, and that's going to equal sine of x over 13. So let's isolate sine of x. To do that, I'll multiply by 13. So that brings the 13 up here in the numerator. We've got 13 sine of 138 over 31.9, and sine of x equals all that stuff. Well, if sine of x equals that, I need sine inverse of all this to get the actual value of x. So let's do that on the calculator. So I did second sine to get the sine inverse, and then alpha y equals to get my fancy fraction. Plugging all that in and pressing enter, that's 15.8. And that's in degrees because it's an angle. Now we have to check the alternate angle as well, because law of sines, you always might have 0, 1, or 2 answers. In this case, it'll be 1 or 2, at least one answer here. But let's see if the other answer also works. So 180 minus 15.8, that's going to give us our alternate angle. And that's going to be, let's see here, 180 minus 16 would be 164. So this is like 0.2 more than that. So 164.2. So the question is, does this actually fit in the triangle with the angle they already gave us originally? Well, 164.2 plus the 138 that they gave us, that is absolutely more than 180. We don't even need to figure out how much more it is. We know right off the bat that that's not going to fit in the same triangle. So that means that this alternate angle actually doesn't work, so I'm going to cross this off. And then the only true answer then is this 15.8 degrees. For this problem, trying to find this missing side, now I know beyond any shadow of a doubt that this is not a right triangle. I mean, just this one angle uses up more than 90 degrees. So SOHCAHTOA is off limits here. What I'll do instead, though, since I do notice that I have an angle and a side across from each other, is I'm going to use the law of sines. So sine of A over A equals sine of B over B. Let me start with the angle side pair that I've got everything for. Sine of 30 degrees over 4. And then I move to the other pair, sine of 135 degrees over the x that we're trying to find. Isolating x, I'm going to have to cross multiply here. So I've got 4 times sine of 135. And then x moves over here, but then I divide by sine of 30, divide it back to this other side. So we end up with a sine of 30 in this denominator. Let me plug that into the calculator. So plugging all that in using alpha y equals to get me my fancy fraction mode here. Pressing enter, we get 5.7. So that's the length of this side right here. And just as a little bit of a sanity check, it's more than 4, which makes sense because 135 should open this triangle more than 30 does. We also should note that there's no alternate answer like with a lot of law of sines problems because we just found a side, not an angle. And law of sines is always going to give us just one side back. On this one, I'm trying to find this missing angle up here. Now, I don't know for sure if this is a right triangle, but I don't really need it to be because I've got a side and an angle that are across from each other. So I'll use the law of sines for this. Sine of A over A equals sine of B over B. So I'm going to start with the angle side pair that I know. We have sine of 25 over 2 equaling my other angle side pair, so sine of x, that's the other angle there, and the side across from that was this 3. Let's get sine of x by itself. So if I multiply by 3, I can say sine of x equals 3 sine of 25 over 2. And now I'll have to do sine inverse of all this stuff on the calculator to see what x actually equals. So on my calculator, I've got second sine to get sine inverse, fancy fraction from alpha y equals. Plugging all that in, we press enter, and that gives us 39.3 degrees. So there's at least one triangle that has these characteristics with this angle in here. There might be another alternate triangle, though. To see that, we have to subtract this from 180 and get the alternate angle. So that's going to be, let's hear, 140.7 degrees. But before we go ahead and accept this as another correct answer, we have to make sure it actually fits in the triangle with the 25 that's already in there for sure. So 140.7 plus 25, does that give me something less than 180? It does. This is going to be 165.7, which is less than 180. So that means that this angle can coexist with what's already there. So we have two correct answers then, 39.3 and 140.7.